our plan has been to take all of the little DQs here and sum them up from the top of the stick to the bottom of the stick. And in adding all of those up, I will be adding up all of the little dfx's that are here, and I'll be adding up all of the little dfy's that are here, and I will take the sum of those all together. I will get a total ffx this way, and I will get a total fy, and then I will recombine those two vectors, and that will give me my answer. Now, there's actually something we can think about before we begin that project, summing up all the x's and summing up all the y's, and that is that the problem that we've chosen is on the symmetry axis of the stick. If you think about that, you can see that if I choose a point here and I choose a matching point there, what forces are produced by those two considered together? So here is the dfx for the point that I've chosen. If I take another one here, take another one there, and find its force, so it will produce a df of this way. And what is going to be the dfy that belongs to that? I think that it's reason you will easily see that the dfy that goes to that df points upward like this, and it's going to have the same length as the one that I've shown down here, although I didn't draw it that way. Do a little better job of drawing it. Okay, so the dfy that belongs to this df and the dfy that belongs to this df are equal and opposite. That is true for this piece matching that piece. But every part of the stick up here has an exact matching piece down here. So when I complete the sum of all of the little dfy's, I will get as many of them pointing up that will sum to 0 with an identical one pointing down, as I have upper half of the stick or lower half of the stick. And that means that the sum of all of the df's in the y direction are going to add to 0. So I don't actually need to do that problem. Well, that's good then. That brings me back to the dfx cos theta part of this issue. And as we've seen, I have an expression for the r, an expression for alpha, and an expression now finally for dq. We can put all of these things together and to make our total force. So if I start doing that, I'm going to express df then. df is going to be equal to, well, it's going to be 1 over 4 pi epsilon naught. That's for the df here. This dfx, 1 over 4 pi epsilon naught, times the dq q, and the dq is now lambda dy, times little q, divided by r squared. You remember from the other board, r squared is the square root of x squared plus y squared, but that's r squared, so that's squared like that. And then finally I have cos alpha, which is right here, cos alpha, which is x over another square root x squared plus y squared. Oops, my chalk is. All right, well, that's squeezed in there kind of small. Let's put it all together down here and look at the entire thing. So I have df x is equal to 1 over 4 pi epsilon naught dq over r squared cos alpha. This was the equation that I began with. The reason that we went to the other board and made a description of r and a description of dq and a description of alpha was because if I want to add up all of these df's, the sum of these df's involves summing over the variable dq, but the variable dq is changing and r is changing and alpha is changing. And so to try to do this integral at this stage would be to integrate a system that has 3 variables. So the work that we did on the other board was to bring everything into a common variable, which we see here. The common variable is all y. So I have 4 pi epsilon naught y dy q x over, and here is x squared plus y squared to the 1/2. Here is x squared plus y squared to the 1/2, and this is the 1/2 squared. So I have x squared plus y squared to the 1/2 power once, twice, 3 times. So that's x squared plus y squared to the 3/2 power. X squared plus y squared to the 3/2. Now this is the final expression that I want to integrate. I'm going to sum up that whole expression. And what that is telling me is that the total force F can be found as the sum of a bunch of little dFs. And the dFs are described as lambda dy times q times x over x squared plus y squared to the 3/2 times the 1 over 4 pi epsilon naught. This is the description of the dF. If I sum up infinitely many, infinitely tiny dFs, I will come up with finally the net force F. This will come out to be dF net. That will be the net force in the x direction. Since all of the y parts cancel out, the net force in the x direction is going to be my net force altogether.